All right, so for this particular problem, we are going to look at how to use Desmos to find the K value. So the first part of this problem, it was actually in the video. It said a hard-boiled egg has a temperature of 100 degrees Celsius placed in a 15 degrees Celsius water to cool. 5 minutes later, the temperature is now 55 degrees Celsius. So we're going to use that information in order to help us find the rate in which it's cooling. And then once we know the rate that it's going to cool, then we can go back and use the information to figure out when will the egg be 25 degrees Celsius. So first thing we're going to do is we're going to place these pieces into our problem, just like we did with the other one. So we have that it started at a temperature of 100 degrees. So if it started at a temperature of 100 degrees, that's our initial. And then it was placed into a temperature of 15 degrees to cool. So that is our surrounding temperature. So that is our TR. And again, this equation is, I think I got it from the notes on the PowerPoint. It's adjusted just a little bit from the one that I used for the video, but it still works the same way, still the same information. And then it says that 5 minutes later, so my time is going to be 5 minutes, and it said that the egg reduced to 55 degrees. So that is going to be my ending temperature. So my ending temperature is what we're going to set it equal to. So I'm going to have 55 equals 100 minus 15. And then I have e raised to negative r, because we're trying to solve for r. I think k was the variable that they used last time. But it doesn't really matter. We're still trying to find the rate. And my time is going to be 5 minutes. And then we're going to add our initial surrounding temperature, which was 15. I think that was in front the first time, but again, doesn't really matter. Now, how can I use Desmos to find this? Well, I'm going to split this up like I've done with any other equation problem that we've done previously. So I'm going to do y equals, and I'm going to take that y equals, and I'm going to set that equal to 55. Okay, so you can adjust it until you see that 55. And then I'm going to do the right side. So y equals, and then we have 100 minus 15, or if you've already simplified, that's great. If not, either way will work. And then I'm going to raise that to negative, now we can't use r, but we're going to use x times 5. All right, and outside of that, we're going to add plus 15. Now, what you're looking for is where those two are going to intersect. Now, you're going to have to zoom in quite a bit because it's going to be a very small number because it's supposed to represent the rate. And my rate is going to be 0.151. So when we go back to substitute this in, we have y equals 100 minus 15, or if you want to make that 85, e raised to negative 0.151, because my k, that's what we decided it was. Or excuse me, not negative, but we did decide it was 0.51, but when we put it in the problem, it becomes negative. And that is going to be with time plus 15. So now we can use that equation and we can figure out how long will it take it for the egg to get to 25 degrees Celsius. So now we're going to use it again, and we're going to say this time we want it to equal 25, and I can go ahead and simplify that. 85, I have negative 0.15 t, so t is what we're trying to solve for because we're trying to find the time. So I'm going to go back and adjust this, so 25 here. And up top, we're going to adjust this so that I have negative 0.151 raised to x. All right, and we're going to adjust this a little bit because we need to go down to 25. And I know there's a lot of noise going on in the background. I'm outside with my kids making this video. And I should get that my time is going to be 14.2. All right, so I hope that this can help you further, but you can basically use Desmos in two-step process One, to help you find the time, and then help you find the rate. And then once you find the rate, you can use the rate to help you make any predictions further down the road.